Hey, feeling good, like I should. When in dark, walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at the homework here for 2.1.2. Our M&Ms have to do with math vocabulary, so we probably have these in our journals from both lessons and last year. You got a variable, that's the letter that represents an unknown quantity. An expression is just a collection of numbers, variables, and operation symbols. And sometimes, remember, students say an expression is like an equation without an equal sign. Well, not really. It's more like an equation is a comparison of two expressions that we know are equal to each other. So this is an example. If saying there's no equal sign helps with the visual of what an expression is, then okay. But it's just a collection of numbers, variables, and operation symbols, and possibly parentheses. The terms are the parts of the expression that are getting added together. So last year we talked about how you would circle the different terms. So here's one term here. This is a big complicated mess, is another term, and then this is a third term. Okay, so if you use order of operations to simplify numerical expressions, you don't necessarily need to be concerned about how many terms there are and what the individual terms are. Just know that you need to go through the order of operations. When you're simplifying variable expressions, you kind of sort of need to be aware of what the terms are, because when you're combining terms, you're always combining like terms. So the coefficient is the number part of the variable term. So the coefficient of this term is 2. The coefficient of that term is 7. The coefficient of this term is technically negative 15 because there's a minus sign in front of it. They should have put a little minus there. And then the constant terms are like just the number. So 8 is a constant here. 5 would be a constant within this term, but it's not its own individual term. Okay, so make sure, when we use these different terms, you want to know what it is that we're talking about. And of course, a factor, just like in multiplication, those are the parts that are getting multiplied together. So in this expression, you could say 3 is one factor, and then everything inside of the parentheses is yet another factor. And then within the parentheses, you could say that the 2, or the negative 2, is a factor with the x. So factors are things that get multiplied together. All right, simplify each algebraic expression. I'm a big fan of sorting them. You may not have like highlighters, highlight all the y terms, and then highlight all the y squared terms, and then highlight all the constant terms. So you can see you're going to be adding up everything that's yellow here, because those are all the like terms with y to the first power. So when you combine like terms, you add the coefficients. Here's 3, here's a 2, and when you don't see a coefficient, it's understood that it's the number 1. So you got 1y plus another 2 plus another 3 is a total of 6 y's. And then of course the y squared didn't have anyone else to combine with, and the constant term, the 5, didn't have anyone else to combine with either. So when all is said and done, this is our simplified expression. So instead of 1, 2, 3, 4, 5 terms, you got 3 terms. C and D, same basic idea. This is a little bit different. Like here, you've got an XY term. There are no other XYs, so that stays how it is. Here, you've got an MN term, and there's no other MN term, so they just stay how they are. But you could combine the 4M and the 1M to make 5M. And you can combine the 1m squared with the 3m squared to make 4m squareds. Okay? The only one of these expressions that you can't simplify any further is B, because you don't have any like terms. If I were to go through and find all the y squareds, that's the only one. All of the xy's, that's the only one. All of the constant terms, this is the only one. All of the x terms, that 3x is the only x term. That's a nice color. There's only one y term, and there is only one x squared term. You can rearrange the order of them, but you won't be able to combine them, because in order to combine like terms, they have to have the same variable raised to the same power. All right, if the tiles have the dimensions shown at the right, what is the name of this collection? All right, so I'm going to go through and identify these. Let me use that. I'll use this one. All right, so we know the big ones are y squareds. The smaller ones are x squareds. Do we not have any units? We don't. Okay. And then we've got our x's are the smaller skinny rectangles, and the y's are the longer skinny rectangles. And we do have some xy's showing up in here. We don't really work with those too often, but for this lesson, I guess we do. And so how many total y squareds are there? There's only one y squared right there. There it is right there. How many xy's are there? 1, 2, 3 xy's. So we'll put that guy right there. How many x squareds are there? 1, 2, 3, 4, 5, 6 x squareds are there. How many total x's are there? 1, 2, 3, 4 x's. And how many total y's are there? 1, 2, 3, 4, 5, 6 total y's. So instead of writing this horrible expression where it's like x squared plus y plus x plus xy and so forth, you want to sort them into their own individual terms. Oh, I didn't highlight that guy. And this entire expression can be written with 5 terms instead of over a dozen, okay? And now we're going to evaluate again, where you take the value of the variable, plug it in, and then work through the order of operations. So I'm not going to do each one of these. If you have a question about them, I'd be happy to answer it for you. But for A, you would take -4 times -1. And I like to, whenever I evaluate an expression, wherever the variable used to be, I like to put parentheses there and put the value of that variable inside the parentheses. So now order of operations, take care of this multiplication first, then you add at the end, and that's how our answer is 7. Okay, take a look at these answers. If you don't agree with those answers, you can let me know. If you know where you made your mistake, make the correction. If you don't know, let me know, and I'll help you make the correction. All right, solve the problem. A typical small bag of colored candies has 135 candies in it, and 27 are blue. Okay, so if I were to write that ratio, 27 out of 135 are blue. At this rate, how many blue candles would you expect if you had 1,000? All right, so we get to practice our proportional reasoning here. This is one of those problems where a unit rate or a giant one, I don't like it. I don't want to do a giant one. I'm going to cross multiply here. So I'm going to get 135x is equal to 27 times 1,000. So it's 27,000. Now we can solve a much more simple equation by dividing each side by 135. And I'll use the calculator here to show you that 27,000 divided by 135 gives you 200 for the answer. So we would expect with this ratio, 200 blue candies out of 1,000. 10 calculators cost $149.50. So in this one, might be good to find a unit rate. And that's really nice that they gave us 10, because anytime you divide a number by 10, you just move the decimal one place to the left. That means that these calculators cost $14.95 each. So multiply that times 100. Move the decimal 2 places to the right, that's $1,495. Times 1,000, move it 3 places to the right, and you get 14,950, and 500 is half of 1,000, so if I just cut this number in half, I get 7,475. Or you could have just gone ahead and multiplied 5 times $14.95, and I guarantee you would get that answer. Let me prove it. $14.95, the unit rate, times 500 calculators, $7,475. And is this the last problem we've got? Yes, it is. All right, so name the coordinates A, B, C, and D. So A is at -4, 3. B is at 2, 1. C is at -2, 0. And D is at -3, -3. So remember, when you're naming these points, these are XY coordinates. So find where your point is on the x-axis first, right? A was at -4, C was at -2, D was at -3, B was at 2. Then identify where it lines up with the y-axis. Now draw a set of axes like this one and plot these points. So E goes at 5 on the x-line, 2 on the y-line. F goes at -3 on the x-line, -1 on the y-line. G is at 0 on the x-line, -4 on the y-line. And H is at 2 on the x-line and -3 on the y-line. Okay, so as we move forward, being able to graph points in the appropriate location is extremely important, and I have complete confidence that most, if not all of you, are experts at this, but it's always good to practice. All right, so that takes care of this homework. Let's head over to today's lesson.
Hey, feeling good, like I should. When in dark, I walk around the neighborhood. Feeling blessed,